So let's start the session. So before going to the page index, let's understand what is a traditional RAG pipeline. Traditional RAG pipeline is what you do. You take a document, you ingest it, you chunk it, you embed it, and then you store. And then when the user question comes, what do you do with that? You try to retrieve top K, and then you pass to LLM to get the answer, right? So that is what a traditional RAG does. Now, this particular thing has a lot of flaws, in my opinion. Okay, so let's first of all discuss the agenda of the session. We are going to discuss that why traditional RAG fails. Then we'll study a couple of more things like what is a multi-hop problem. Then we'll go towards understanding how humans navigate document, because page index simulates that thing only, that how humans read anything, it just tries to simulate that thing. Okay, then we'll understand what is page index, what is the tree generation, and walk through, and then we'll compare. Now, point is this, that in today's world, AI world, right? Every day a new framework will come, a new package will come, a new strategy will come. If you open YouTube, everyone will say this particular thing killed this particular thing killed this, right? I mean, point is that how do you make sense of the new technology, that whether it is good to take or not? If it is good, what is the incremental cost to take it, and so shall we switch or not, right? Because when you will be working in companies, if you just directly go to your seniors and tell them, okay, I found this very cool thing, we should implement this everywhere, that sounds like a very naive person who does not have experience of handling things, and like every time he sees a new things, he just gets excited with it, right? So we don't want to be that person. We want to be a person that, okay, a new technology is coming, we want to understand it, we want to see where does it fit in our existing scenario, does it give me enough lift that I can take it, and what is the extra cost or effort required to make it available in my current system, right? So we need to answer from this level to make sense of any technology. And it is not related to page index, could be anything. Any technology that you're going to see in future, always have this view that how it is going to come in your regular life. Okay, so let's start with that. First of all, you'll understand why traditional RAG fails. Okay, so now, can anyone tell me before I start, what are the problems with traditional RAG?
There could be context rot.
Okay, context dot can be there. What else?
It can't link multiple documents. So even if there is a relation exists, we will lose that context.
Yep. That's a very fair point. Anything else?
Unnecessary retrievals of documents
Okay.
if there is no re-ranker.
Fine. So let's start with it, right? First of all, what we are going to understand that what does RAG actually do, right? We need to understand the that thing. Wait a second. Okay. So what does RAG actually do? RAG takes a question and it tries to match with what. So for example, let us say you have a question, and where did it go? Okay. In traditional RAG, what will happen? You will get a user question, okay, and so you will have a question, and then you will have some. Let's say you have stored few things which you will try to do the top K from them. Let's say you have some chunk stored, and you will try to let's say chunk one, chunk two, chunk three, and chunk four. Okay. So what does traditional RAG do? That it calculates the embedding similarity between your question embedding and the chunk embedding. Okay. So what does it do? It tries to do the convert both text into embeddings and tries to calculate the cosine similarity or any other type of similarity to see how close are these two vectors. So one caveat in this is that we are talking about similarity, we are not talking about relevance, and this is very important thing. And if you come to page index document as well, this is their official page, they also talk about this, that semantic similarity is not equivalent to relevance. Can someone give me an example for this? If you know, what is the meaning of similarity versus relevance?
So it means that there is a lot of so semantic similarity means that there are words that are same in both the embeddings, but the meaning, the context is not getting answered through that similar words.
Okay. Okay. Yep. So this is it. When we say similarity, what we try to do, guys, please mute if you're not. Please mute if you're not speaking. So okay. Yeah. Now let's come here. So what we are trying to say is that when we say similarity, so two texts are similar when embedding when they talk about the same thing. Okay, but relevance is something different. So let's see this with an example. If I come here, that let's say this is a scenario that user asks that who invented Python. Let's say. So now when you try to do vector search, what types of chunk are more likely to come? Let's say that my expected answer is that this person invented the Python. But which type of when I do a similarity search or vector search, which type of chunks will come on the top?
Chunk number 1 with the point 92 followed by 89 and then
No, that's I'm saying they're coming, but what type of chunk? That's what I'm asking. That the chunks which so if you see the question is who invented Python. So the
right.
statement
Anything which has Python will be fetched first instead of like who invented. Anything
exactly.
which has Python would be fetched first.
So things which the chunks which have more, which are talking more about Python or some inventions, okay, they are more likely to come. If you try to see who invented Python, so on the this is the table on the left hand side. This is a score. This is retrieve chunk, and this is the problem. So this is the chunk. Python is a popular programming language used for AI ML. This is relevant to the question. So this is similar to what question is there, but is it relevant? No, because this cannot answer this question. Similarly, Python supports multi-programming language. Python is widely used, blah, blah, blah. And let's say this particular statement, which might not be present in the right word, but it contains the relevancy, right? And this will come somewhere below. So if you see, this is the embedding matching that I did in the document. I saw that it was coming out to be 0.7. So what is happening that with just when we do a simple vector match, we get high vector score, but that particular chunk is not relevant to get the answer. So the top 5 results are about Python, but none contain the answer. The correct chunk is buried at rank 12. Do you guys get this point? What I'm trying to say is similarity versus relevancy. Okay, let's take another example, the password. Okay, so user says, how do I reset the admin password? Now, what do you actually expect to reset the admin password? There will be some commands or there will be some series of steps which will be written that follow this journal, follow this command, and you will be able to reset the password. But if I see, I'm getting password policies, ensure this, administrators can manage user account and password expiration, blah, blah, blah. This all is coming, but this is okay. This is similar, but this is not relevant again. So my main chunk, which could have answered me, was lying somewhere below, but it was not in top 5. Okay. Similarly, same thing, a legal this is a legal contract trap, right? What is the termination notice period? Now you expect some answer like this, but you might get this agreement may be terminated. This is totally taking to some other direction. Okay, this is talking something else. This is talking something else. So this is what I mean to say, that you might have similar chunks, but they might not be relevant. Okay. Now one last example. What was the total company revenue for 23? Now what you want to do, you want to go through this particular page and get the answer, but you are getting these scores and the relevant which is present at page 112, it is coming at the bottom. even though the difference is very less, but let's say you were doing top 3, you would not have got this answer, right? And that is the problem with the traditional RAG, which we want to overcome, that I am just blindly picking top K based on matching, but not on intent. Okay, so similarity does not mean intent, but what I need in a real retrieval, if I talk about a real retrieval, I need intent rather than just similarity. Any question in this? Anyone? Okay, so I hope you guys are clear.
Yeah, clear, Satvik.
Now let's move to the next part. Okay, multi-hop problem. So what is multi-hop? Now, traditionally what happens whenever you ask questions to a PDF or any documentation, there are two types of problem. One is a simple fact lookup. What is a fact lookup? You will ask who invented this, what is the sales in this, tell me 3 facts about this, right? So these are pretty straightforward questions. Multi-hop problems are those where what happens that questions are jumbled. I mean, it's not straightforward one factual lookup. It's basically one question, output of one will be input of other. So multiple reasoning is involved. Okay, so when the answer requires following a cross reference between the documents, that embedding cannot see. Embedding will only see that okay, that get me, for example, let me take a very simple example here. You ask a question that what are the top 5 reasons of company failure? Let's say this is the question that user asked. Now, your document does not contain any such text like this. Document, let's say a document is talking about companies' strategies, companies' shifts that company did in last quarter, what all additional projects it took, what all major, like which all tasks it was involved in. Okay, it will contain only that. So when you try to do a similarity match on this, you will not get anything. Yes or no? And this simple example, summarize me the document. Now, when you apply a traditional RAG on this, what will happen? Let's say user asks summarize me the document. What will happen? Your document, it will retrieve those texts from document which where let's say some summary is mentioned. But is that document summary? No. By document summary, I want the entire content of the document and summarize that text over. So what would I ideally want is that read through entire sections, major sections, and form an opinion about it, rather than doing a simple fact lookup. So these type of queries are called multi-hop queries. And in production systems, you face such kind of questions only. Like people, though, even if you think like traditional NL-SQL, where people ask database queries in natural language, that how many customers, let's say, what was the fraud rate in last month, compare it with last year, and tell me, give me a report. Now, this type of question is not just a fact lookup. It requires analysis. It requires understanding, breaking the question into different steps and doing the right retrieval for each and then forming an opinion. So this is called a multi-hop query. Okay. Now, so let's look at this. A very simple example. If you see, this is a question. What is the total value of deferred assets? Okay. Now, this particular information, what you want to look up in a document. Now, the step 1 is vector search retrieves financial section. So you'll get something like this, the report, the increase of $2.1 billion. Let's say you got from one chunk this information, but the query is asking what is the total value of deferred assets, not the increment. Okay. In the bottom of the section, in the chunk, it mentions that page 77 contains the line Appendix G provides detailed information. So in a chunk, you would be provided that this was the increase. If you want to see the actual numbers, go to Appendix. Now, a traditional RAG will totally fail here. Why? Because to do the right answering, what should have been done? Let's say this was your question. Okay, now this chunk, it says it contains this information that increase of $2.1 billion. Okay. And it also says that refer to appendix for details. Okay. Now, appendix, let's say this is a separate section which contains a table and other things where it contains the actual, let's say the user was asking total deferred assets, right? And this information is present in appendix in a table. Now, it does not matter whichever retrieval strategy you apply, you will never be able to get this appendix table in top K. Why? Because it does not contain the exact the similarity of getting this particular thing will not be there, because this table contains a lot of information. It's not only for deferred assets, it contains a lot of other information as well. Whereas this chunk was talking about deferred assets, but it was only talking about incremental. It was not talking about the exact value. So an ideal scenario should have been that, okay, I should first read this. From this, if there is any reference to other section like this, then I should go from here to this section, read this, and then answer. Right? This thing is not available in traditional RAG. There you just do a top K and you blindly just want answer over that. So this is what it talks about, that the answer required 2 hops. Financial dissection, first of all, go to the financial section and then go to the appendix, and then you get the answer. Whereas vector search can only do 1 hop. Is it clear? The multi-hop problem to you guys? If you have any question on this, please ask me. And why I'm building is this, because this is the exact thing we will be tackling in PageIndex.
Satvik, could you explain in more simpler terms?
Which thing?
This multi-hop failure.
Okay, let me explain. Let me do one thing. So let us say this is a research paper. Okay. So this is on which topic? This is some topic. Let's say enhanced retrieval augmented large models with iterative. Okay, this is iterative retrieval. Okay, let's say this is a documentation. You want to chat with it and you want to get an answer like, or let's do one thing. This will not answer. Just trying to show you a better live example. Let's see. Okay. Okay, let's see this document right now. This is a Nike documentation. It contains 10 pages. Okay. If I come to the bottom right now, it is at the top, it is talking about full year revenues were this and something, some text are coming here. Okay. And what do? You chunk it, and here is a table at the bottom. This but net income, which talk, let's say you want to know diluted net income in 25, whatever it is. You want this value, let us say. Now, what happens at somewhere there, a text is written, let's say the diluted net revenue increased by this or something. Okay, it is written somewhere in the document in the middle of section or anywhere. Now, when you try to do a retrieval, what will happen? That it might not go to the table, because see, if you try to do, where did the table go? Okay, now this table, when you try to create embedding of this table, tell me, will it come close to diluted or will it come to something else?
Gonna try to dilute.
It will not come to dilute, right? This table is not talking about only dilute net income. It is talking about net income across various things. So what I'm trying, let's say user asks, what is my diluted net income? Now this particular table does not talk about that only. It talks about a lot of things. So when you try to do an embedding match, that total diluted income, there is a very high possibility that this table does not come, because this table is talking about net income in some other aspect. Now, there might be a chunk present which is talking about diluted income. Let's say a chunk present, a chunk says that diluted income increased by 2%. Refer to appendix. Okay, let's say this is your one of the chunk. Now this is, you have another chunk as well, and you have another chunk as well, and you have this particular appendix table. Now what is happening, what the scenario that I'm telling you right now is that this particular thing comes in your top K, but this table does not come in your top K. What is the reason?
Because the table do not have anything related to diluted
Because
income,
table
so
does
it will
not
not
contain
get.
things related to diluted income, or even if it contains, its similarity is less, although it contains, but table is not
Yes.
only talking about that, right? So when you do the top K, when you compete against this chunk will not come, because this chunk will win. This chunk is only talking about diluted income. That is
Right.
the first thing. Did you guys get this? Now,
Yes.
let's say it retrieved this chunk. Now, what was my original question? Total diluted income. This chunk be able to answer this?
No.
No. For that, it has to go to appendix. And this table, this chunk has written that go to appendix. But in RAG, do we do multi follow-ups? We just retrieve at once and give to LLM. We do not do multi retrievals, right?
Right.
Right.
That is the problem with RAG.
That's
That
correct.
what will happen, that you are assuming that the answer to your question is written in some beautiful paragraph out there, but it is not. The answer to your question will be scattered across the whole document, across different sections, and just one simple lookup will not give you the answer. You will need to do one lookup, then second lookup, then third lookup, and then you will get the answer. That is called multi-hop. Clear?
Yes.
And this is a very practical scenario which I'm telling you. It's not something that I built in my mind. It's very practical scenario. You can think of like that. Now this research paper that I was showing you right now, in this, it's highly possible in this, right, that someone wants to know something. Now this is a small research paper. Someone wants to know what is the accuracy of chain of thought in this, something like this. Now somewhere else something else is written, which has, because when you will chunk and embed, this entire text will go. So unless your summary is proper or it is exactly matching question, you are giving a possibility that this table might be skipped, and I don't want that. For a that, like, a table might come, might skip, right? I want that table should come always. So for that I need to do a multi-hop query, that okay, rather than answering everything in one, we do step by step. This is just like chain of thought prompting that we do, that we do not automatically start getting answer. We ask that okay, let's follow this step 1, step 2, step 3. This way I will be able to get answer irrespective of what. So that, this is what is multi-hop query. Okay.
That makes sense.
Now, so now why multi-hop query fails with vector search? The reason is very simple. When you do on traditional lookups in company's Confluence page, they are very small pages. Yeah, there you won't even see this difference. The problem will arrive when you have financial statements and legal documents and tax documents, right? There you will see that this kind of issue will come. So if you see, all type of other documents are coming, but the main section which was required does not come. So that's why you need to do multi-hop query. Okay, so that is the problem, that is a multi-hop problem which exists in traditional RAG. Just wanted to tell you that. Yep.
Like one question, like does agentic RAG
Yep.
And
Agentic
if we
RAG also will
do
not solve
agentic
it
RAG,
directly, right? Agentic RAG is what?
uh,
You use RAG as a tool. You have not improved your RAG pipeline. You're just
yeah,
calling RAG tool whenever required, but still your RAG pipeline needs to be fixed.
The fundamental problem is not fixed with just
Fundamental
adding.
problem of RAG is not fixed, right? In agentic RAG, you're invoking RAG via an
oh,
agent, but that is still not solving the problem. So now let's say
yeah, but like if we add some a React framework in that, like every time it retrieves a wrong chunk, then it can go again. Then if there is appendix,
even
there
if you
is
add
some
React, even
hyperlinks
if
and
you
all.
add React, your retrieval process is still not correct.
Okay, okay,
Do you get my point?
okay. It's all, yeah, it's all about retrieval, right? I mean, if we like if we do agentic thing in that, it doesn't solve it.
It doesn't solve it. Agentic thing can automate. It can basically select the RAG whenever required. But is the RAG solved or not? Right. So the world of RAG is still not solved. That's what I'm trying to convey.
Okay, got it. Yeah.
The retrieval
Next.
problem is basically not solved. Retrieving the wrong chunk is not solved.
Yes. So uh, that is the thing. Now again, another problem with some regular chunking is that without checking the document structure, you destroy it. You chunk from the middle of the document and where you lose the context, right? For example, let's say this is a document. 3.1 is income statement, 3.2 is balance sheet. Now if you do a random chunk, what will happen? That okay, first chunk is fine, second chunk it randomly split it from here, and this chunk 3 does not make any sense here. So there you lose lot of things. So uh, these are the major flaws: that topic match not answer, solution not retrieve, relevant clause buried, multi-hop problems, and chunking breaks the context, right? These are the major problems in a traditional RAG pipeline, and that is why we want to look for a solution which is more robust, because we are now right now not solving the intent, we are trying to solve the similarity. But I want to look a solution which solves the intent of the question. Okay. So now to move ahead, let's try to understand a little bit one example. That first understand how do humans navigate through documents, and then we'll bring the same idea in the page index. Okay. So for example, I think I told in morning class as well this particular part, but let's say you are reading a biography of Sachin Tendulkar. Okay. Now you want to find an answer is in his biography, which is finding an answer in a 500-page biography of Sachin Tendulkar. Okay. Now the book contains everything. The book contains his entire cricket life, right from his birth to where he is now, whatever he achieved, and there will be different things, right? Per childhood and teenage, like there so many stages would be there. Now let's say you ask the question: what was Sachin's mental state during the 2003 World Cup final loss to Australia? Okay. Now this particular question, it it is not present. You need to understand that it is not present in one's place. Okay. So let's say there is a book in front of you, and you have to find this answer to this question. What would you do? You tell me. As a human, forget about drag, forget about any algorithm or something. How would you ideally search this information if I give you a book and I say you have to find the answer in 15 minutes? What will you do?
So
Most probably
basically,
looking at the index.
Yeah, please go one by one. Yeah.
Yeah. I was saying like we could go to the books index
Okay.
where we can see all the topics defined with the page number, and with respect to that name that has been asked, we can quickly search on that page. That
But
would be one.
let's say there is no topic related to this 2003 World Cup final loss specifically. So what will you do?
so
Uh,
Sachin's autobiography, we'll check if it is chronological. So when 2003 World Cup was there, chronologically, what was Sachin's career during that phase? We'll find that page or that chapter of the book and see if there is any relevant information there about his mental state during that time. That's one
Okay.
way.
Okay, that's one way. Anyone, any other approach?
Satvik, what if for each of the chunk, one question, okay? Suppose if we create logical chunks without losing any of the like section data, without leaking one section to the other chunks.
I'm not only
And
talking about chunk right now. I'm just talking about how as a human you would find.
no, actually, I have a doubt actually, and if we read our data and if we have a very good sense of our data, and if we ask the LLM, okay, we got to know that okay, one section it has some reference to like appendix A or B, and what if we add that in our metadata, and during retrieval, when we retrieve the data,
But
we
is it a universal solution? Like you
no
will
no
be
I'm
biased toward some
No.
document, right? Let's say you know one document very well and you know that okay, for this document I will always refer to this metadata. But is it a universal solution?
no, actually it is not, but for a single document this approach can work, no?
No, but we're talking about a general solution, right? Let's say single document which you have read. Let's say I give you a document which you have never read. Will that logic apply to that?
No.
No, right? So we are trying to find what is a generic solution to find uh, to explore things that we don't know, and how can we retrieve them quickly. Okay. So coming to this book question, guys, anyone, any other approach?
One possibility, but it could be time taking. Like if you're going through the book, initially a person's introduction or biography is written. So just skimming through the headers, the paragraph headers, that could be one
Yeah.
approach where we can come across the World Cup where it is mentioned, and that paragraph roughly may give the answer to this.
Right. Okay. So let me tell you how would I do that. You guys, your answer is correct almost. What I will do that I will first of all check table of contents of the book, right? That okay, these chapters exist. Now in that chapter, it will contain his birth, his initial cricket career, when he first made to the team, and all those things. Okay. And my question is that what was Sachin's mental state during the 2003 World Cup? I will try to look for chapter which talks about 2023 World Cup, or maybe World Cup, or maybe anything related to this, which, like, out of all the, let's say I have 50 chapters, I will see which chapter is most likely to contain this answer. I will go to that chapter. It might not contain, but I'll make a guesswork that okay, I think here people are talking about World Cup, so there's a possibility that this answer might lie there. It will not be present in his birth section, right? That's for sure. But I can know that I'll make a guesswork and I will go there. Let us say I go to the World Cup chapter. In the World Cup chapter, now there also it's a big chapter. I will see different headings, and I will skim. Suppose that World Cup chapter initially is talking about how India was winning the matches earlier on. I will skip those things. I'll go to the that particular section where there is a mention about India losing the World Cup, and then specifically look for if there is any mention of Sachin's emotional state, mental state. Right? That's how I will navigate without reading. So what I'm trying to do, I'm trying to read the top level index first, then bottom level, then going step by step down, right? So if you see what I will do, I will open table of contents, find chapter on 2003 World Cup. Then I'll go to, let's say I go to chapter 18, which is the 2003 World Cup campaign. Okay. Now scan to this also I will not start reading from scratch. Right. I want to actually find the right place, area where this answer could be lying in. Then I will move to, okay, if is there any section related to finals, because it was a big event, so there will definitely be some mention about it. Okay, so the subsection final in Johannesburg. So most likely my answer is there. What I will do, I might take this chunk and I'll just read this and get the answer. So I'll read the passage, okay, where Sachin has described his emotions after the defeat, and it will get me the answer. Now, what I will further do, that it, let's say it gives me answer, but I'm still not satisfied. I want to do more reading. Then what will I do? I'll check cross reference, that in that page has he mentioned anything, reference to any other chapter, any other things in life where which cross connects, right? So for example, more on this period in chapter 2 dealing with the loss. So there is an entire chapter about it which is mentioned in that particular section only, and I cannot get to know about this without reading this. So step by step, I came to this particular part, and there while reading, I realized that okay, he has mentioned something more about it in another chapter. So from there, I'll jump to that chapter, I'll read it, and then I will understand everything. This is how humans read book. Do you guys agree or not?
Yes.
This is called iterative reasoning as well, that you try to narrow down the approach. Once you read that, you build your knowledge, and from there then you see, okay, I don't know the full answer, then I might need to navigate here there as well, right?
Actually, we
So
can take this as an example of if anybody has given CAT or any competitive exam, the reading comprehension quiz is basically this, right?
yeah, it's kind of that only, that you first of all see that okay, my paragraph is split. One para is talking about only facts, one is talking, let's say the question is asking what is the user's the author's opinion. I will skip the facts, I will look those paragraph where author is putting his opinion, right? I'll read those and try to answer. So something like that only, that how do you skip whenever a big document is presented to you, how do you find the most relevant context, right? Humans do it always. Now that we want machines to also do this. Okay, so this entire algorithm which I just explained you is what is called page index. Okay, so the fundamental difference is that uh, vector ag matches the words in the query to word, right? And what does human do? They reason about document structure to locate the right answer. And this is what page index also do. It replicates the same human strategy inside an LLM. Okay, so now we will start with the page index. Any questions so far? Okay.
Seems good so far.
Okay. So now let me just quickly walk you through the algorithm that PageIndex has mentioned. And wait a second. Where is it? PageIndex website. Okay. So if you come, let's read this what PageIndex has mentioned. Okay. Let's little bit do the reading part. Page index reasoning based RAG mimics how humans naturally navigate and extract information from long documents, as we discussed. Unlike traditional vector based, this approach uses a dynamic iterative reasoning process to actively decide where to look for. Okay. Now they have given an algorithm, very simple algorithm. It's not very complex. What did they say? That first of all, read the table of content. Now your question might come that table of content might be present, might not be present. So right now I'm assuming that it is present. If it is not present, we will take a step. So first of all, read the table of contents, understand the document structure, and identify sections that might be relevant. Okay, then select a section. So from that you will select a section. Let's say out of 20 chapters, you select the relevant chapter. Okay, choose the section most likely to contain the useful information, extract that particular part. Okay, extract that part, send to LLM to say that okay, this information I have got, this was the user question, is this information sufficient to answer the user question? If the LLM says yes, then you will proceed to answer the question. Otherwise you will reiterate the steps. Now you'll come back to step 1. Again you will find the next most relevant index that is present, and you will keep on looping till you get the answer. So once enough information is collected and complete, you can basically answer. So what is happening? You're taking a question, reading the table of contents, which is called TOC. From that table of contents, select a section, and inside that section as well, you can go down further, just like we were doing in Sachin's case, right? Extract relevant information. Now check, use an LLM to decide whether information is sufficient or not. If it is yes, answer it. Otherwise, repeat the process. Okay, so this is what page index talks about. Now there are a lot of things beyond this, but first tell me, is the algorithm clear to you guys? That how is it working?
Yes.
Any question in the algorithm?
How is this selection being done? Is it done by an LLM?
It will be done by an LLM.
Uh,
Yeah. Yep.
so in
I'll
the
show you
first
how.
iteration, okay.
And one more question, Satvik. TOC is already existing in the document, or we construct the
POC is
TOC first?
existing. We are assuming it is. If it is not existing, we will have to create it. I'll show you how it will be done.
Right? That is a fundamental assumption that there are TOC
So that's it.
present.
No, if it is not there, then also there is a way, but you will have to create it. The main thing is that TOC needs to be there. If it is not there, you have to create it. So there is a way that PageIndex tells that how to create TOC. Okay. Any question? Anyone? Okay. So let's do one thing. So I created this website for you guys. Let me. Okay. So just one second. I just wanted to show you a particular thing. Okay. So what eventually we do is that we take our whole whatever is we take our entire content which is present and we convert it into a tree-like structure, which is I'm calling it, which is a JSON structure which we have to create. So instead of creating your traditional RAG with embeddings and all that, you will create a JSON like this. I'll walk you through how does it look like. So if you try to read this JSON, at the top it contains document name that this. So I use this on a particular research paper, and then you will see title, introduction, and so everything will be like node, subnode. So if you see this diagram, is it? Yeah. Sorry. So this kind of diagram. If you see, you navigate through different nodes and come down, and you reach to a particular topic, and then you decide that I want to pick this particular part. Okay. So let's show you quickly how it works. So this particular diagram is clear, right? Now what we have to do, it's a two-step framework that whenever a document is given to you, you need to create the tree that I showed you. It's basically a JSON tree, which will sit with LLM whenever you ask a question, and based on that, it will ask you to navigate that, go to this section, fetch this, and do that. Okay. So first step is building this tree, the entire thing. Next, once the tree is built, basically the indexing is done, then you will ask the question. So a user question will come, you will go to the tree index, you will find the node, you will keep on doing. I'll show you hands on how does it work, but this is an overlay two-step framework which we are going to talk about. So first step is tree generation, and second step is how to find the answer. So let's go about understanding that how the tree is generated from this. Okay. So it is an iterative process. So what do you do first? First of all, you take up. So let me explain you in the draw.io diagram, then we'll come here properly to understand. So let us say you have a document. So you have a PDF present with you. So let's say you're talking about a PDF which it contains different pages. So let's say this PDF contains 50 pages for now. Now I'm just taking a small example of 50 pages, but we can of course enhance it. Now what is going to happen that the step one, so we are studying right now the tree creation. Okay. Tree creation. I hope you guys understand what is tree, right? Tree is basically just like heading, subheading, and further subheading, right? So you want to create everything in that tree so that you can navigate properly. Now, what will happen? You will take this PDF. After this, you will first of all split it into different pages, and for each page you will count the number of tokens. So what the step one will be that split this whole PDF into split in 50 pages, and in each page count tokens in each page. That is there with you. Okay. Now, what I'm trying to show you is that, let's say you take it and you will create, you'll split into each section, and you will have 3 scenarios, which you need to understand. The scenario 1 is that your table of content is present. Okay. Second scenario is your table of content is present, but page number is missing. In a lot of documents, you will see table of content, but you will not see page number. So that's why this particular type of scenario is also there. And the third scenario, which is there, is that TOC is not present. So our eventual goal is to construct a JSON like this, where I will have a title. So if you see, I have a node introduction, and this is talking about that. Then I will have different node. So each node can have a parent node, can have a child node, because if there's a subsection to that, there will be a subnode present, and if it has a parent, it will have a parent ID as well. So now let's talk about the scenario when table of content is present. That is the most easiest part. So what will happen? Let's say this particular thing contains your table of content. So what you will do, you will take this whole part. So what you have right now, let's say 50 pages. So you will split this whole into 2 sections, or any number, that it's up to you. So take, I'll say, split the document chunk. So basically what you had, let us say 50 pages comprise of 50,000 tokens, for example. Okay. Now you don't want to pass 50,000 tokens all together to LLM once. So what you will say that, okay, just split it in 2 parts, 2 chunks of 25,000 each, and in each chunk, each page will be there, and on each page there will be something like this. So there will be a, you can say, like, page ID. Okay. And it will be present there. Now you will be passing this entire document to an LLM first, saying that this is the index that is present, and this is how the page is structured. So you will ask it to adjust the page numbers, and basically just to verify that if all the page numbers are correctly present as per the table of content or not. So generally, if there can be an error, there can be an offset value, right? So you will just verify all this, and after this, once you get all this, you will apply a particular function which will convert this list, this chunks, to JSON. So this particular part will be handled by LLM. So you have entire document present, and you're just sending it to LLM to create an index base for you, which is nothing but a JSON tree structure like this, and based on the documentation, where you are specifically asking it that create node ID, start index means start page, and end index means end page. Okay. So this is how it looks like. If you try to see, each tree will contain a node ID, its name, its description. This is very, very important. For all the node or the heading, you need to provide a description that this particular heading talks about this, and metadata. And then if there is any subnode present for that, you will provide that. So this way you will create a tree structure like this. Any question before I move ahead?
I have one question.
She's present.
Sorry?
Right now, you just told, that we are sending everything to LLM for it to convert
Yes.
into JSON forms. So
Yes.
this is happening in the case when TOC is present.
We'll be sending to LLM in all three scenarios, but right now, because our TOC is already present, so we don't need to create it. We can simply send the content to LLM as well to generate this. Did you get or not?
So we will be sending the table of contents separately,
Not
and
table
then
of content. You will send the entire document to LLM
okay,
in batches to
in
convert. Think
batches.
like this: you have a document present which is perfectly indexed, but you need to store it somewhere. Okay. Now the question will come to your mind that why are we passing the whole document, and that is the basically trade-off of this particular approach, that you have to pass your content to LLM to process it and convert to a JSON tree. Okay, so that is I would say an setback of this, but there are a lot of advantages as well of this mechanism. So what you need to do, you need to take, so in case your TOC is present, you need to take the document. Let's say you had this document 50 pages. You will split them into 2-3 chunks, or you can split them in any batch. You just need to do a batch query to LLM. You can make it parallel as well. Okay, so that it does not have to process a lot of tokens together. So maybe 50,000 tokens, you can send them in 5 batches of 10,000 tokens each. The main objective of this is that to send it and ask it to create a tree for you, to convert this into a JSON like this, which I just showed you. So over the time, when you keep on sending multiple documents, this JSON tree will keep on creating, and the current sections, current headings, so headings of the same level will be present in the same JSON level. And for example, if you see this node 6, financial stability, it has subnodes, node 7 and node 8, right? So what does it mean? 6 is the main main heading, and 7 and 8 are subheadings of that.
So
Does it make
Satvik,
sense?
in the appendix section, if it is like a later, if there is some reference to our financial stability in later pages, so will this subnodes get updated automatically? Like
Yes.
future page? Okay.
Yes. Any
Okay.
question?
And one thing, one question, like you said, like we can put 500 pages of document here. So it's like, is there any like context window limitation?
No,
Because like
I'm coming to
500
that.
pages of
For
document.
tree
Okay.
creation, what are we doing? We are splitting, we are reducing, we are not passing the entire document, because PDF could be 50 or 500 pages as well, right? So I cannot pass the whole PDF at once to LLM. So that's why I will have to
Okay.
split it into batch sizes. And remember, in LLM, you do not need to send in series. You can create batches and send them together as a batch request, and it will create this JSON for you, right? So remember, we
Okay.
have
So
still
you're saying
not
like
started.
uh,
Yeah, please go ahead.
you're saying you're putting this the document in chunks, right? Like for example, for like 50,000 tokens and all. So you're putting
Yes,
all these things in chunks,
I'm
or it is
putting chunk,
happening
but
inside
remember, I am
in
I am converting them into I'm putting them in chunks. But you need to remember two things. I have a table of index. I know that chunk is from which section, and eventually I am creating a summary for each node as well. So even if I'm sending chunks, each of the chunk will go in the right section. It's not that it will randomly go in any random section, because each chunk will be created subnode based on its document positioning instead of a random chunking.
okay, okay, okay.
Satvik, what about cross document reference? If if suppose if we take a example of a employee, he can have references in multiple domains, and if we want to create a like a RAG system on top of that, how will this page index be created?
In which
Like if
example?
if imagine if we have like two documents, 2 or 3 documents, okay,
Yes.
but the entity has reference to all these 3 documents. How will this cross document
Yeah, if
reference
3
be?
documents are there, I have an example for that as well in the class. I will show you when I run this. I have this example called as multi-document track. Okay. What do you
Mm.
do? You store all of them in a single index. Think like this. In a traditional rack, when you upload multiple documents, you store them in a single vector index, right?
Yeah.
And you are able to retrieve based on embedding. So same thing here also, this JSON that will be generated like this that you're seeing here, it will contain other. So this is a document name. So another document name will come, which will be in the right order in hierarchy of this. So this is one hierarchy. In the same hierarchy, you will see the second document as well. So that when you later start on reading, you know that this particular index contains 2 documents or 3 or 4, as many as you can create. Clear?
But how
Can
is
there be
it solving the problem of linking document like this kind of cross reference question?
I'll come to that when I explain you how answer is getting generated. Okay. Then
Okay.
you'll be able to link it better. Right now, what we are doing simply is we are creating a JSON like index, which is if you try to see, I have this main document name, then the structure is title, then start index means the starting page. So this particular title is starting on what page? Introduction, it started on page 2, finished on page 2, node ID 001 because right, and text, the entire text of that, basically the entire chunk, and the summary of that this particular section talks about this. Okay. So far, is the index creation clear to you guys?
Can there
Yes.
be in this PDF, can there be tables also?
Yeah, there can be tables as well. So tables are nothing. They are just like text only, right? Text with slash marks high. So they can come here. Main thing is what you're trying to see. If you see any document, let's say this is my research paper, right? Now what is happening? If you see this is the title, then abstract. So abstract will become what? It will become one section, introduction, one heading, then all the text into this will go into the introduction node. Now, does the introduction contain any subnode? It does not contain. So let's move to second, 𝗧𝗵𝗶𝘀 𝗟10. Now this is the second section. Now, does this contain a subnode? Yes, it contains a subnode, right? So this particular text will be present in the subnode for that particular chunk. Now, this is another subnode. This is another 2.3 is another subnode. So in this way, you'll understand the document structure and you'll create a JSON where like this. If you see, where is it? Attention tree. This is attention. Okay. Yeah, I'll run the command. I'll show you. Okay. So this is how it will be created.
One
I'm just
question.
checking one
One
example.
question.
Yeah, please. Yeah,
So
please.
this JSON, this tree structure, it is generated by LLM, or is it the page
It is
index
generated by
functionality that
LLM. It is generated by LLM.
it is generated by LLM? Okay.
So we are relying on LLM to generate it. That's why it takes some time to build the index. So we are increasing our LLM cost, but we are increasing our accuracy. So as I mentioned, it is a trade-off that you you increase your cost, but you also increase your accuracy. Okay. So for very advanced like complex documents where you need like accuracy like 98%, 99%, this is the right solution. But again, I'll come to those things first. But first is JSON creation, right? Is it clear to you that what is happening? Even if you have 5 documents, what will happen? You'll create a JSON tree of entire document like this by passing to LLM. So you will have a table of content based on table of content. You will create your main nodes. Okay. And after that, you will put the entire content of the document into those particular nodes as per the location of the document. So if you see preface, introduction, background, model architecture, right?
Yes,
So this
yes.
is how you're creating the tree. Now it contains the entire text. And first tell me, does this solve the chunking problem? The chunks will be created as per the section. You do not need to provide any chunk length, right? Every section, subsection will have its own, will be created properly. There will be no like cutting in middle or like cross-referencing, those kind of scenarios here. So you'll create this. Now I cannot pass the entire text here. So what will I do? I'll create a summary for this. So this is where LLM comes in. LLM reads all this and it will create this summary for me. Okay, because remember, I'm creating index for one time only. I don't need to do this again and again. Whatever cost is there, it's just one time. Okay, so it created the summary for me. All clear before I move to the next part, that how answer is being retrieved.
Satwik, so here basically we are just like chunking the document based upon the
We're not
tokens.
chunking. We are not chunking anything.
Okay.
LLM
we
is
are just
automatically splitting based on the table of content.
okay. But we are not sending the entire document at one go. We are doing batch processing. So
We are doing
parallelly
batch
we are
processing.
sending.
Yes.
Okay. So but the LLM will receive the entire document and then create a JSON based upon the entire document.
Yeah. So what we'll do, let's say you send 10 things. Okay. 10 files, 10 small files. Okay. LLM will start creating this JSON. Based on first, it will create a JSON. Now, when you send the next JSON, next document, it will fit into this. So let's say how it's going to get created. Let me do this. abc.json. Okay. So what will happen? Let's say you send 10. You are sending 10 files. Now, section 1 will be, let's say that chapter 1. Okay, and some content is there into this, and then you have, let's say in the first you had chapter 2, and then you had some content here. So step 1, this got created. When you do step 2, when you send more content, either each of these chapters could be updated or next chapter would be created. You get what I'm trying to say? Over the time, this JSON, after once the whole batch process is completed, this whole JSON will be completed. So it does not matter how you split those, the main document, because eventually you're creating a single JSON only from all of that. And you're creating it iteratively. That first, I got the first document, from that I created this JSON. Second, I enhanced it further. Third, enhanced further. Third, more. And that's how I will reach to a big JSON like this. Clear?
So here instead of like we normally chunk and then do, so maybe here and there data is lost, but here LLM is deciding based upon the headings and subheadings and all, like
Yeah.
how to create these chunks. So it's much more smarter.
It's
way,
much more
maybe.
smarter. Thing like this. Let's say this is present, this particular whole part. Now, if you would have splitted it, what you would have said that, okay, split on every 1000 token. You would have splitted this somewhere this. Now, now that will lose the context. But what is happening now? You are passing this whole text to LLM, and LLM knows that your document contains this structure, introduction, background, and it can see that this all text is part of this background. So in the nodes where we are seeing this, it will put all that text into that particular node. So it will not split it in between.
Okay, so we
Yeah,
don't
please.
have to use any Pinecone database here.
You don't need any vector
we-
database for this.
Yeah, so we only have to prompt the LLM that we need a JSON format for this particular
Exactly.
document.
Exactly.
That kind of. Okay,
Exactly.
okay, got it.
Yeah, please. Someone was asking anything?
Yeah. So Satwik, maybe it's a basic question, or like, so if we know the like current process of how we are doing, I'm just asking. So if we know the structure of the document, we can use the hierarchy and get in the same structure, right? So like what the hierarchical chunking is doing,
Hierarchical
or
rack is there, but there you still need to do the multi-hop reasoning, right?
no. I'm asking like why do we need to identify the structure? Do we need to go with LLM, or we can create this hierarchy and ask LLM to only generate the summary of those sections or the subsections, right? That was my
But
question.
if summary will be generated, you still what will you achieve with that? Tell me.
So like what it is doing, it's creating the JSON, right?
Yes.
So while it is creating this JSON, what it is doing, it's going with a section, subsection, like it is, think of this as a knowledge graph. Okay.
Yep.
So that's
Yep.
what the hierarchy also doing the same thing, right? It's creating the knowledge graph for me. And I can, for each chunk, or not talking about the chunk, like for each section or subsection, we can extract the entities or whatever the keywords, all those things, right? The metadata.
Yep.
Like how is it different between the knowledge graph versus the
Those are two
paging?
different approaches, right? In knowledge graph, you try to connect. You do not create document structure. What you understand is that, okay, my document is there. There are different nodes and relationships, and I match them, and then I store them as graph. There, the document structure, each node structure might not be maintained because one node might be referring to multiple things, right? There, you are talking about how things are interlinked. Here you are talking about how this document is structured, so that if you have to go and understand it, this is the way to understand. We are not creating any nodes and relationships yet. We are creating summaries for each sections, so that whenever a question comes, LLM can see the sections and understand which section should I go to. So it's a little bit different from knowledge graph. There might be in knowledge, we are not exactly creating entities relationships here. So it's a different approach to see what accuracy we get as compared to knowledge graph. Do you
Understood.
get it?
Yeah, understood.
Okay.
Thank you. Yeah.
So now if you see this, where is that prompt? I wanted to show you guys. Find the physical location and one more prompt. Just 1 second. So this is one prompt. Check title appearance, TOC detector. Then we have check if TOC extraction is complete, transformation. Yeah. Check the table. This TOC content, full table of contents. Then page index. TOC index, table of content. This I'm just like, yeah, this is the TOC transformer. Yes. So basically what you do, that you give the whole text, and if you see, there are different LLM prompts which are given, right? So I'm just trying to show you that you create table of content, that this some content is given to you. You have to create something in this pattern. I'll come to this. I'm just trying to find. Okay, let's meanwhile this is happening. First, tell me, is it clear that what is like code walkthrough I will give you, but are you guys clear with what index are we creating? Any question so far?
Yeah, we are clear.
Okay, so now the next part comes, that how does it answer the question, right? Now that, okay, I understood that I have created a lot of, if you try to see that my entire document is still present in the JSON in different nodes, and still, how do I actually get the answer? So there comes the second part, that remember what we are going to do, it is going to be an iterative process. So let's say a user asks a question here, that get me something, for example. So user will ask a question. Now, along with LLM, you will have this index tree always with LLM. Okay. Now, we are not passing the entire tree to LLM because that it does not make any sense. What will it contain? It will contain the on a very higher level that these are the top headings, top nodes, basically level 1 nodes, and these are their description. So technically, if you try to see in the tree, you will contain this information. Top nodes, you'll see top nodes, then you will have its description. Okay, and whether it contains child, yes/no. Okay, so what is happening? You're asking a question, and this index that we created, we are passing this entire tree to index. Now, think like even if it's a 5,000 pages document, this index tree will still be around how much? At max 2,000 token, 3,000 token, or let's say 10,000 token, not more than that, and which is fine with me because I don't want. I mean, I'm not still going 50,000 tokens. I'm fine with a 10,000 token. So what will happen? A question will come and this index will be passed to LLM. So these two things will be passed to LLM. Now, what will LLM tell me? That this is the question, this is a description. It will say that to answer this question, I need node 3 and 5. So this is what LLM will respond. Clear? Or if you provide child summary as well, it will also provide that I want node 3 and 5 with their respective, let's say child 1 and 2, something like that. So what will happen? LLM will respond to you that I need this context. So you will go, you have to write a code. Now there comes you will extract LLM output, that what a node LLM is asking. You will go back to your main tree index where you have stored things. You will extract those particular nodes again, and then you will send to LLM. Okay, so you had this question, you had this tree, LLM respond, I want this, then you passed all this to LLM. What will now if the answer is clear to LLM, it will say I have got the answer. Otherwise, it will ask you to further provide more nodes to answer. So if you try to say this is recursively iterating over the entire node, that what all things are available to me. So let's say out of 10 nodes, initially it said I want node 3 and 5. It will check node 3 and 5 properly if they are sufficient to answer the question or not. If node 3 and 5 are not sufficient to answer the question, it will ask you for more information in form of nodes. Otherwise, it will directly answer from this. And this process will keep on repeating, which I was mentioning, that take question, read TOC, select a section, extract relevant information. Is the information sufficient? Answer the question. Otherwise, no. And you will keep on doing this to get the answer. Question, or it went above your head? I know this is a little bit complex to understand, so we can take time, but please ask your questions, whatever you have. I know there will be a lot of questions, even I had when I read it for the first time.
Yeah, hello.
Yeah, please.
Yeah, I have a question. Right now, you are converting the JSON from and which LLM?
I use GPT-4 model, that you can use any model.
Okay. Yeah, if you are, I am going with an VLLM serving with any of the open source model, it will be better in terms of not getting as much better of like GPT-4.
Yeah, model you can select any, right? That it is model agnostic. This whole process is model agnostic. So you can use a very heavy model as well. You can use small model as well. Let's say there's a good model which is good in summarizing long text, right?
Yeah.
And so you can use that open source model as well.
Yeah, just asking because if we are creating a large number of requests only for creating JSON,
Yep.
so if we have GPU servers of own having hosted there also.
Yeah, you can do that as well. I remember when I did in my company, what happened that we were using this Claude Haiku model, and we were indexing lot of documents. So it used to give rate limiting because we send multiple requests all together to LLM, right? It used to give
Yes.
a rate limiting that, so the process used to stop in middle. Then we had to like properly control the inputs. The biggest setback of this is that you are technically passing the entire document to LLM. Does not matter once or in a batch. That is a very heavy that's a heavy cost. And if I show you, I have covered this as well when we'll come to the last slide, that this whole process is expensive. I'm not saying that it is a cheap process. If you compare with this regular, it is 50 to 150 times more expensive indexing, and 2 times more costing per query. So it's not something like you will do on your every document. You have to strategize that whether you want it or not, if you want, on what scenarios where accuracy matters a lot to you, thing like that. So when you have journals, you have finance documents which are very much deeply nested. There, a traditional RAG with whatever optimization strategy you apply, it's not that easy to get the right answer. There you can try something like this. Okay. The whole idea of page index is to improve the accuracy. And if you try to compare the other strategies as well, let's say if you have studied about book rag, if you have studied about light rag, and if you have studied about a few other mechanisms as well, they also try to convert this only. They try to convert things into a tree, and from there they try to learn. Now some use LLM, some use embedding model. So this field is still exploring. I would people are still exploring the perfect way. This is just a start, I would say. In coming days, you will see them think like this. If you can do prompt caching, you can significantly reduce your cost. So if you enable prompt caching and other strategies, let's say you reduce your parameters of your model. If you specifically create a fine-tuned model, all this costing can come down, and this can be a very good use case to certain companies. Okay, so my experience says that this is not a complete replacement to RAG. Right, but this is a very good thing where you achieve close to 98 to 99% of accuracy. So okay, now let's come to the flow once again. Anyone any doubt in that? There are actually a lot of things in explaining, but this is the base thing to understand what we are doing. We are taking an entire document and we are taking its table of content. Based on table of content, we are creating an index JSON structure, and then we are iterating through that JSON structure through using an LLM one by one. That first take a question, take the tree, let's say take this tree, and ask LLM whether it can answer me from this information or not. If it can answer, it will answer me. If not, it will prompt me that no, hey, I need this nodes 2 and 3 as well. I think that might contain the relevant answer. So you will need to write code to fetch them and then make another LLM call to get the answer. So this LLM call will keep on going till you find the right answer. You can put a certain limit that after 3 iterations, I will stop, just to control your cost. Okay. Any question, anyone? Or it? So as I mentioned, there were 3 scenarios. One was with page numbers. This what we discussed was the most easiest things, I would say, that LLM converts the raw table of content into structured JSON. Okay. And then it basically fixes if there is any page number mismatch, and then you apply your things. But there are 2 other scenarios. One scenario is table of content is present without page numbers and no TOC at all. This example, there you need to do 2 things. First of all, you need to ingest the whole document. You need to find a strategy that you will ingest the whole document to an LLM first to create TOC for you, and then use that TOC just like we were using the scenario A. So section B and section C is the worst scenario where you don't have a TOC. So you have to ingest your whole document to an LLM once and get a table of content, and then use that table of content to generate the JSON. Okay.
Satvik, if we don't have TOC, but we still have headings, subheadings, so can't we do it directly?
No, so you still need to understand, right, where things are existing. headings are there, you still need to write down code to understand them, right? There is an example of markdown file I have taken here. The markdown files contain headings, subheadings. If you see this this markdown file is there, okay, where you have different headings, okay, but you still need to create table of content, because think like this. Remember, what is the main thing while answering question? We are passing user question along with what? With a tree of the document. So if you don't have the table of content, how will LLM prompt you back that, hey, I need this information? If you see this, what I was passing, question plus index tree, which is what? It's a TOC. So even if you have heading, subheading present in your document, you still need to create TOC, because this TOC will sit with LLM always for a reference. It's just like the index page. It needs to have that to know where to navigate. Do you get my point?
Yeah, I mean, we can't, can it be possible that we just simply give all the headings as a TOC, or it won't get the right answer?
You will need to tell the page number as well, because if you don't tell page number, the extraction of the text that you are seeing here, again, that you'll understand more when you read the code, the extraction of whole text, where each node is starting, where each node is finishing, that is very, very important. So just by passing heading, you will not understand. You need to know which node is it, when is it starting, when is it finishing, so that you can do the right content extraction. If you don't do that, you will have the headings, but you will never know main thing, the text inside each heading. You will never know. You will never be able to store in this JSON like this. That's what I'm trying to say. Still, if you have questions, guys, please ask. I'm here to answer only.
Potential, all you need is also a research paper. Then it also won't have TOC.
Yeah, this
right?
research paper didn't have TOC, so it created it. I'll show you by running the code. So see, what does it do? It first of all check title appearance. So there are different functions. I'm just trying to show you that you have to create. Again, you don't have to create. PageIndex automatically provides this, so you just need to import it. So that is the good part. Check title appearance. Check title appearance in start. Then check title appearance in start concurrent, and then TOC detector. Check if TOC extraction is complete. So what do you exactly do? You start with the title extraction of a particular point and see till what page is it going, to understand the hierarchy. Otherwise, you will not be able to understand that. That is the point, that you want to convert this whole thing to a JSON of trees. Now, JSON needs to follow the right hierarchical order as present in this document.
Yeah, true.
If so, and you will need to navigate through this. To navigate through this, you need an index paper, like a TOC, so that you know which thing is existing where, and so that you can ask LLM you can ask that, okay, I want to get information from this node, from that node. So because eventually this node number is very, very important.
Karthik, where will the raw documents be stored? The PDF in this case?
Which raw document?
Our PDF document that this particular index is referring to. Suppose if it is attention is all you need paper.
Yeah.
So is it like in the disk that we store
You
as
can
PDF?
store it anywhere. You can store it on cloud. I have just stored it here. You can store it anywhere. Eventually, you will download in a workspace and you will create this tree. So what question you need to ask is that where will this tree exist?
And during retrieval phase, we will be like using the summary to find out, right?
Yeah. Very simple.
Sections.
Question
Yeah.
comes, you will check. Let's say you get a question. You will first see, index will see, okay, there is one document in this, and it will check whether there are multiple documents or only single document. Okay. So it will check that. So first information. Second, which all headings are present, which all subheadings are present, and which all nodes basically, and what is the summary of each node. So from that information, it will get its first idea that to answer this question, I need to get to this particular section or node. From that, it will say that, okay, from this node, I want these child nodes. So you will provide them, and then LLM will process them and see if it can answer. I know it's still going above heads. You can ask me. Okay, guys, tell me what is the what part are you not understanding? That is it the retrieval that is not clear, it is the indexing that is not clear, or something else?
So, can you please explain the case when there was no POC? Once again,
Case when
there was no table of contents.
no table of content, right? No, let me come to that. Okay. So this is the third scenario when you don't have any table of content present. So what you will do, so step-by-step flow is that you will wrap every page with basically what you will do for, you'll split every page, and inside that page you will write down a tag like page 1. So let me parallelly create this as well. So let's say you will take a page, right? Now the page does not contain anything. You will create a like this page 1, something like this you will create. Similarly, you will create for all the pages that you have. Now, what you don't have right now is table of content. So now we'll split into groups. What we'll eventually do that a lot of tokens are there, so we can split them into different parts. Send group 1 to LLM that generate hierarchical tree structure from this. Okay. So what it will do, it will first of all create the tree, and from there it will create a table of LLM, read the pages and creates a table of content, identifying headings, hierarchy, pages, everything. And similarly, now you'll follow the other process. So first LLM will create a table of content, then it will create for each page that where is that section starting on that page, and where is that ending, and all kind of things. So if you see structure 1, title this is page 1, this is page 2, this is page 3, like this kind of data you will be getting. Is it clear or not? Or you want in more detail?
Like,
Uh,
Yeah, please go ahead.
okay. So I'm still not sure like how, like I'm seeing just now that they are processing 700 pages of document. Like I'm still not sure like how this the LLM is not failing in doing that, because if you see ideally, if you put this big document with so many words and like 700 pages, like it fails, right? Ideally it fails in processing all these
No,
documents and answering this.
why will LLM
Like
fail?
I'm
You
not
are
sure. Like if you say like TOC, like JSON is getting created, but
yeah,
for that it has to go through all the pages, all the sections, right? In a go, then it decides like which section
not
to
in
put
a
in this
go.
node and
That's
which
why we are
section to
doing
put
batch
in that.
request. We are splitting our, let's say you have a PDF of 10,000 pages. We are splitting your
Yeah.
PDF from 10,000 pages into pages of, let's say 10,000 pages are there. So we are sending 10,000 batch requests to LLM to create that. We are not sending one
Okay.
request
Okay.
to create entire entire index. So 10,000
Okay. Okay.
pages,
Okay. Okay. Okay.
10,000 requests are going to create one. Think like this: 10,000 people are working to create one building, right? So people will
Uh,
work on the same building and construct it one by one. So it's just like that: one person creating a big building or 10,000 people creating one building. So that's what we are saying. So when you give the whole work to LLM at once, it will not be able to do that. So what we are doing,
Yeah.
taking a document, splitting it into different things, but what we are doing, we are creating the same, we are asking it to work on the same JSON, so that after 10,000 requests, the entire document for entire JSON for that particular document is created. Is it clear?
Okay. Okay. Yeah. Now I got it. Yeah. Nitin, go ahead. Yeah. Thanks.
Okay. Anyone? Any other question?
One last thing, when you do this batch thing, so do they have this shared memory or shared document work, like,
Yeah.
and
Sorry. When batch happens, what did you ask?
like batch, when we do this batch processing, everyone
Yeah.
will have different memory, right? Different state. So
It will have different
and they are
state.
working on
That
the
I agree. But everyone is working on the same document, right? So let's say this is your LLM. So let's say what you're having. You're having batch 1, okay, and similarly you're creating batch 2, batch 3, batch 4. Okay, let's say you have these many batches. Batch 2. This is batch 3. This is batch 4. Now the JSON file is there. Okay, this JSON file is same, and you have an LLM instance that is available in cloud. So this batch request is going, LLM does not answer them immediately. So this will be talking to this, and while the LLM will be writing to this. Correct? When batch second will go, it will talk to this. Its content will also be written to the same documentation. Batch 3 also, it will talk here. The content will be to the same document. Batch 4 also goes, but what will happen? Content will be written to same document. So even though they have different memory, but the artifact that is there is the same.
so this the batches are different, and the LLM is common, or the LLM requests are also uh, they will have a different memory, right? Just the main JSON is the same or shared one.
Each batch will have its own memory. It will not be shared with anyone else. So LLM will have, about this auto enhancing, right? Whenever multiple requests come, what do you do? Auto scaling. You know that, right? So multiple LLM endpoints, same multiple versions of these LLM would be created, so that they can handle all those requests parallelly.
I was not aware of that. Okay. Yes.
Yeah. So this is a auto scaling called horizontal scaling. If you guys have heard about this, what is horizontal scaling? How does batch processing work? That increases system capacity by adding more machines or nodes. So technically, same model, same configuration, but multiple. So each will be handling each batch. That's how it works.
And where will that JSON be also stored somewhere, and it will be accessed by everyone?
It will be accessed by everyone. Yeah. So we will think like this. This will store that this JSON is stored at a location /opt/JSON, let's /abc.json, right? So same path will be provided to it. So everything will be writing to the same thing only. So even if they are independent of each other, but still they are writing to the same file.
Yes, got it.
Make sense? So batch request is not like that same LLM is handling all that. It will explode, right? So what do you do? That batch request means how, like those who know about Kubernetes scaling, it is that as load increases, it automatically spins up container so that it can handle the request, because the configuration is same, the result will be same only. So you will be getting the response here. Okay.
Okay. Got it.
So now talking about this, when no TOC is present, what happens that you basically when no TOC is present, you have to first create TOC. So two requests are there. First, you have to pass to LLM to generate a TOC. Then you have to pass TOC plus content again to LLM to generate the JSON. So two steps are there. Okay. Now let's do one thing. So now just try to see this, how this RAG query is working. Let's try to just read it. Okay. So once the tree index exists, query is passed. Okay. Now your user question and the tree index, that JSON that we create, this will sit with LLM. Now the phase one will be that LLM selects node IDs based on tree that I need these IDs. Then phase two will be extract the content for those IDs, and phase three will be generate the answer. So if you try to see the phase one, send tree structure, titles, summaries, not full text to LLM with the user's question. The LLM returns relevant node ID that it needs. Now, then you will do the content extraction. Collect the full text from selected nodes. This gives complete unbroken sections, not random chunks that we're creating, because we are now taking the entire content of a subnode or a node, and then we'll ask LLM to answer. So if you see, this is the prompt. Given this document structure, which sections are relevant to the, so this prompt it will be using, that given this document structure, that this is the tree that we'll be providing, and this is the user question, tell me which sections are relevant to the answer. So LLM will respond 007, 008. Now you will take that 007 and then you will search that, and then you will keep on repeating the process. So why does it beat vector search is you are entirely depending on LLM reasoning. The context quality, you are not splitting tokens in between, you are splitting, doing the complete sections, and it understands your document. It's not like I am answering based on similarity matching. I'm answering based on intent, because LLM is reading the summaries, and that's how it is able to answer. Right? So that is there again. And the last part is if something fails, it has a, let's say you get this answer, node 7007008, you get it, you give the content, LLM says, no, I think this does not contain, let's do a little bit more research. And this is how, if you can relate this to your vibe coding, have you guys seen that when you vibe code, you say something to code, it does this only, that it will say, okay, let me search this, let me explore this function file. No, it does not contain, I might have to explore further file. This is the same technique that is used. The coding agents like Claude Code or other that you see, GitHub Copilot, they don't chunk your code base like indexes and store them. They do the same process. I will explain this in code rack session, that how codes are indexed by LLMs and how do they get answer from that. It is the same thing. They read the entire code base. Something called as AST structure. AST structure. Abstract syntax tree, this is called. So LLMs understand the intent of the whole code through this tree, and that's how they're able to navigate faster. We have implemented the same thing to document. So those who know about code rag, again, I will explain in one of the future workshop as well, but this is how it works. For those who are seeing this for the first time, might be a little bit daunting, but don't worry about it. Let's understand the main concept, that we are creating a knowledge tree which is well aware of itself, which understand the whole document, so that whenever the traversal you're doing based on logical reasoning rather than semantic matching. Clear? Any question? So I'm going to walk you through the examples then very quickly, and then I'll close the session for any Q&A if you have. Okay. So remember, I have pushed this to GitHub. So this is the GitHub for this. If you'll come, you'll see these examples. The 10 examples, I have 8 examples, sorry, I have created here. You can run them on your own and check how it is working, but still let me run them one by one and show you that what exactly it is doing, what exactly each is responsible for. Okay, so let's come here. So what I will do, I'll first of all delete this this entire JSON. I'll create them from scratch. Okay, so let's see this first example. We have basic tree generation. So what is it doing? See, I'm using this GPT-4o model here. You can use better one as well. And so what is it doing? It will go through this research paper that I have. This one. Where it go? Attention is all you need. It will create the index for this thing. Okay, so let me simply run this and show you how it is working. Please, I've added proper logging, so do read at each step how it is working. Okay, so step 1, download the PDF, configure page index option. Now it is generating tree. Remember this, it might take 1 to 3 minutes. Remember, this particular thing does not contain TOC. So what it will do, it will start finding first of all TOC pages, and it will not be able to find that. You will see that.
Right.
So let's see the logging. See the logging properly. So it says no TOC found, right? So what did it say? Okay, process no TOC. Now it will take the entire document and now pass to LLM to create TOC and fix whatever issues are there. And because this document was very small, the result was very quick for LLM to process, and it created this. So if you just read this, yeah, so it followed parsing PDF, starting with TOC pages, no TOC found, process no TOC. When it created the TOC, then it validated a document, checked everything, checked the right tree structure, and it is completed. Okay, so it created like this. This is a tree: preface, main node, introduction, background, model architecture, and then sub nodes, something like this it created. And see, this whole tree is created. If I come here, attention paper JSON, right? So it has created a JSON file like here. And this is the plain TOC that it created: preface, introduction, background. This is what LLM responded. And that's how we have stored it. So this is the first example where how does it create TOC? What is the algorithm behind it? Again, you'll have to read through the code in more detail to understand individual things, how each is working. That I cannot explain because of the time limitation. But the entire concept is this. First, look for TOC. If it is not present, create it. Then create JSON from that. Shall I move to the next example? Next example is just for the markdown, so I can skip it. We did for a PDF. If you run this example, it will do the same thing for a markdown file. It will create the same thing. Now let's run through a simple RAG pipeline. So what it will do is, let's see, third example. So this is the third example. Where is it? Yeah. This example, it loads the attention paper tree. It runs 3 different queries through full 3-phase pipeline. First, LLM reasons over 3, select nodes, extract full section, and generate answer. Okay, so let's run this and see how actually we only created tree earlier. We will now create tree as well, and we will create answer as well. So let me run this. So this tree was present, so it didn't generate, it automatically took it. So that's why I mentioned that you just need to create index once. If there's no change in index, it will pick up from the cache and your cost will be saved there. So let it generate the answer, then we will study it step by step, how it generated. So let's come here. This step we had done earlier, total nodes available 26. Now, question, how does multi-head attention work and why is it better than single attention? So is it a single fact answer or it's a multi-hop question answer?
Multi-hop.
So multi-hop. I have asked 2 questions using AND, right? So LLM reasoning over tree structure. LLM says to answer the question about this, why is it? We need to focus on sections that specifically discuss multi-head attention and its advantages. The model architecture section, particularly attention subsection, is crucial as well. Its detail. So yeah, are you trying to see that it is able to understand the document structure properly, that where this answer will probably lie, because it has the index, nodes, subnodes, everything. If you guys want, you can. I can give you a minute to read this. So just read this much. you'll understand the reasoning of LLM. Just read from this. If you want, I can zoom in. Sorry. Is it visible? Text is visible, right? Or shall I zoom in? Yeah, please read this reasoning. And then it says selected nodes 4, 5, 6, 7, 8. It says that to answer this question, I need information from these 4 nodes. Clear? Now, what will we do next? We have to write down code that whatever node have been extracted, provide that content to LLM. So this. So we will extract the full text from the selected node. In the phase 2, extract the full cut text, and context size is 28,897 characters, which is how you can assume to be 60, 70,000 token, whatever it is. Sorry, I spoke a little bit.
7,000 tokens.
So now it will generate answer. It sees that based on this, I can answer because it actually extracted a lot of nodes. So it is able to answer your multi-hop questioning. If there were sections which it could not answer, it would have asked again for the reasoning. Same thing. What training data were used? How long did it take? Now, through a regular RAG, you cannot get answer to this in one go. It's like very difficult because it will not be able to find the semantic search. But now with LLM reasoning, it says I want in these nodes, and then it will be able to generate, and so on. You will see. Okay. So the key takeaway is no vector database. LLM reasons over document structure, and every retrieval is explainable. So that's how the percentage accuracy is very high. And trust me, just to tell you that even if you're thinking that no, we are sending an LLM, this might not be good. What is the use case? This repository, don't trust me. This repository is trending #1 on GitHub, right? So there's a reason people have started adopting it because a lot of use cases specifically require this level of reasoning. Okay, so now let's just quickly running the remaining example. Now this is a multi-document RAG. What does it do? It downloads 2 paper, generates index. So someone was asking that what if 2 or multiple documents are present? It will download both of them, generate tree for both, build a document registry. It will build a document registry and store both of them into that. And then 2-phase retrieval. First, select the relevant documents, then searches nodes within them, synthesizes a cross-document answer. That's how it costs. Okay. So let me just run it. So first it will download the documents. Again, you can have them stored if you have. So same process it will follow. First and try to create a TOC if it is not there, all those things.
What is the input documents here along with attention? The other document is?
2 document and I think this page index paper is there. Let me just cross check which one I added. RAG paper. Okay. This one, RAG original paper, and attention is all you need. So yeah, this one. So first it created tree for this, attention is all you need, and next it created for this. So it is working on it. So this is if you see results, attention, tree, and now it will get a RAG tree as well very soon.
So here it skipped recreating TOC for attention is all you need, right? It says already exist. 11
Yeah,
sections.
If it already exists, it will not create it. You have to code it like that. Okay. So once you download it, then you do build document level index of first pass selection. So you create a document registry, 2 documents you put there. Now a question: how do attention mechanism relate to the retrieval augmented generation? Now you have expanded your question. You are doing a multi-document asking a question which involves answer from multiple documents, right? So you're saying how does it relate to RAG and what are the key innovation in both areas? This type of question you can never answer through simple RAG. So what it will do first, it will say select relevant documents. It will say, okay, I selected attention and RAG, 2 documents. Then to answer the question about this, and in both, we need to understand the foundational concepts in both mechanism and find, right? So it selected both of the documents. The document this details about RAG. So both documents are needed to comprehensively address the question. Now, searching within relevant documents, it will go and search like below each and then try to answer from this. So that's how it is working. The process is same in each, that try to identify the relevant nodes, bring them to LLM and let LLM answer. Okay. So now see attention, this and RAG are significantly enhanced, like it is able to answer technically based on the documentation. So two-phase retrieval, pick docs first, then search within them and then combine them. Now, just one more thing, example. So this is multi-document RAG. You can also do using vision RAG, where what will happen, instead of sending to regular LLM, you'll pass to a GPT vision model where it will vision model will create that JSON for you. So it's kind of same, only just that we are using OCR to generate it. Now, same, this example talks about the same thing, but different document. One is a PDF, one is a markdown. So that is, you can check. And last is page index versus RAG. So it's just a comparison between them. So just to show you, just guys, 5 more minutes and we are done with the session. So okay, so it tried. So I created a local FAS for vector search. So it tried to get from that as well. So give me a complete picture of how authentication works end to end. So it will do the top 3 and it will try to get the answer. Then in page index, it will do the logical reasoning and get the answer. And then you can actually compare that which answer comes out to be better. So in my opinion, this one was better. What I explored, again, this is something we'll explore when you run it. So yep, that's it guys from my end. I think this is just a introduction to page index as a concept. What does it do? What all things it is capable of? The biggest drawback of this method, as I mentioned, is the cost, which is 50 to 150 times from the regular. But again, it's a trade-off, because with higher cost, you're getting better accuracy. So depending upon your scenario, you can try it. Now, this particular thing is available using self-host. So there are multiple ways they provide it. You can actually, it's a subscription, I think, but you can use the self-hosted way as well, like I am doing. You can take the library and run it locally, and if you have to deploy, I think they have some cost and all that, but again, that's for later. Right now. Yeah, guys, anyone, any question, please ask me, otherwise we are done with the session.
Hi, Sachin. Are you able to hear me?
Yeah.
Yeah, sir. Just like a normal RAG, whenever only some chunk of it has changed in the whole document, then we
Yeah.
are doing all these asking and all, we're replacing that embedding respectively, right, in the director database. How
Yeah.
we can go the same approach in this one? Is it liable or it will
So
take
whenever
much
a
cost?
text change, right?
Yeah, exactly.
Yeah. So think like this. It's just like a batch process. You don't need to run the entire pipeline. whatever text change, you can just send that and it will automatically adjust in the tree wherever it should logically fall.
Well, first we need to check whether where the text has changed, and relatively we just need to send that back process on that particular node, right?
Yes, yes. Let me check questions from the chat if there are any. What is index? Index is this only, right? Index is what we created here is called index only. This whole JSON that you're seeing, we are calling it index. So how it is different from knowledge graph? Knowledge graph is where you create nodes and entities relationship. So we are not creating any nodes specifically. No, we are relying on LLM's ability to summarize and understand. That is how it is different from knowledge graph. That if you try to see on a very broader level, the main thing is this summary. If this summary is not present, then this whole process is useless, right? So where is this summary deriving from? This summary is we are deriving from LLM's internal knowledge, that what does it mean, based on its document understanding. So we are not specifically creating any nodes and relationship. We are relying on LLM to understand the document completely and summarize it properly. That is how it is different from knowledge graph. So knowledge graph has its own use case. This is own use case. You can compare both of these approaches on a same set of question and see which one comes out to be better. In my opinion, this will come out to be better because it is more recursive approach to identify the right answer. But knowledge graph will might give you instead of 98, might give you 95% with less cost. So that is something up to the user, what you want to take. There's another concept called as book rag. Again, I will cover that in the course in the evening today. But that you take documentation and you create chunks, and then you create knowledge graphs to relate those chunks, and then you iterate over them to answer. So there is a thing called, you guys can explore as well, book rag, and it's a hierarchy. This is another approach to answer this. Now, if you see internet, there are a lot of approaches people have tried. So what does it do? That it takes the hierarchical chunks, plus it takes some knowledge graph as well, and puts them together. So that's how you're able to answer better. There's another thing called as light rag, if you guys have heard about it. So light rag also does similar kind of thing. Yeah, if you see, it takes the document graph based text indexing, and then it takes the knowledge graph and then it indexes them together to form entities relationship and context, and then they try to see. So light rag, I think as of now, it is the best solution to a general rag, because it is not the problem with page index right now, that it is expensive. Now with light rag, that cost thing is also not there. If you see this table where they have given a very good comparison, that these are the 4 type of document: agriculture, CS, legal, mix, and on 4 parameters they have evaluated percentage. So if you see this legal documentation, which is the most complex one, light rag versus naive rag, it comes out to be 83.6%. This comes out to be 16.4%. So as complexity increases, light rag performs significantly better than other and in less cost. So light rag also we will cover in the course. So yep, just to give an idea. Each API cost will be spilled. That's what I said. There is cost, but there is accuracy. You're getting 98, 99% accuracy. So things like for enterprises, it does not matter much. If they have limited data, and which is very much, they want a very robust solution, they don't care about spending money on that. Like, it's just like that. What will happen? It's less than the salary of an intern a company hires in US. So the companies don't mind like doing that thing. It is production grade. Yes, it is. That's why it is there, right? People have started using it. It's not some theoretical concept. It's well used in industry, and people have significantly started using it. So it's not some demo that I am walking you through. See this case study, PageIndex lead. So this is some scenario, is a reasoning based RAG system. It achieved 98.7% accuracy on finance bench for this, as compared to GPT-4o 31%, perplexity 45%, some other mechanism 94%, and this page index 98.7%. Deployment, they provide you Docker, you can deploy using a Docker container, or you can take their subscription. So they provide two methods. They come as a SaaS solution. You can also take the way I have done and deploy in a Docker container. So you have to download their library and use their functions, deploy in a Docker, and I think it is MIT license, so you can use this. Page index. Yeah, so you can check their page for pricing and all that. I also forgot what is their pricing, but documentation pricing is here. So if you see developer free trial, so this page index also come in form of an MCP. So you can use that as an MCP and API. You don't need to worry about, you just give your documentation. It will automatically create trees, everything. You don't need to worry about that. So you can use this method. Pay as you go is also there, and scale plan $50 a month. And I think there's an enterprise plan as well for companies. So we, like in my company, we have used this enterprise plan to answer, but yeah. Repo is available on Git. Just Google it. It is available there. Just Google PageIndex GitHub. You'll find it. Anyone, any other question, please? I know this was little bit advanced, but try to go read about it. Just give it few reads. You will understand. Use ChatGPT, use Claude to understand, explain the scenario. I'll share this GitHub repo with you where I have all these examples, so you can run them locally as well. You just need to configure your. If you see, I have configured my OpenAI key, so you need to configure that. Rest it will work. So that's it from my end, guys. If you have any question, please feel free to ask. Otherwise, you can drop off. Have a good day, and then I'll meet you in the next session.
Thank you, Satvik. This was very informational.
Thank you. Thank you, guys.
Thank you.
Yep. If someone still wants to understand, you can DM me. I will try to explain or share resources as well, whatever I can. But this is
Hello.
not some. Yeah, please.
Yeah, just a last question.
No, you can ask
Uh,
as many. Please.
uh, if we are building a traditional RAG system or a vectorless or any of the agentic, I have a just
Yep.
question: how when just I have ingested a self attention one
Mm-hmm.
paper in it in the vector database, then if a user asks first about the first question is like, tell me about transformer, and second question is question is handled for the retrieving part.
I think I lost your voice. First question is, what is transformer? What is second question?
Yeah, it's a follow up question from the user like,
Okay. Yep.
tell me more about it, like.
Yep.
So that how that questions are handled in the production rack systems, like.
So they will, first of all, it will not be able to answer because every request that you send is a separate request, right? So
Yeah.
it's just like what will happen that let's say this is your user which is asking question. You are basically asking how do the follow up questions work, right? That's what you're asking.
Yeah. Yeah.
So let's say this is there and this is your RAG system, which with it
Yeah.
could be an agentic RAG, regular RAG, whatever it is. Okay.
Yeah.
So multiple ways you can handle this. First of all, you store remember when do you know about lang graph?
Yeah, yeah, of course.
In lang graph, we create state, we store messages, right?
Yeah,
Every
yeah.
conversation we store in a state.
State.
So after every conversation, what do? You put all this in a memory. Okay.
Yes.
Every information goes in a memory. You basically do a short-term memory here
Yeah.
for that particular thread. Now, when the next question you will ask, along with question, you also have to pass the short-term memory or previous states, so that
Yes.
LLM can understand that this much it already knows, and now I need to process the next follow-up question. So
Yeah.
one method is this. Second method, which you do, is you take the question, you do something called as query reconstruction module.
Okay.
Okay. And then you pass to the RAG. So whenever user asks lame questions or questions which are not proper, this query reconstruction module takes the query, pass historical message, or tries to create a proper message from that, so that RAG can retrieve it better
So we want to rewrite the query on the based on the history messages.
based on history messages. Yes.
Yeah. So I'm just having a doubt about how production system works. Like they also rewrite the query for the RAG retrieval.
They rewrite the query. Lot of things they rewrite the query. If you guys have you seen this Uber RAG system? Uh, this is Uber's. They have put it officially, enhance agentic RAG. So you read this article, you'll understand how do they handle user query, how do they follow up queries, all those things. So this is a very good article to read. You can read from this.
Sure, sure.
But
Sure.
this
Thank you so
in
much.
short, let me tell you that they do this only, that they add a
Yeah.
module called as query reconstruction. If
Yeah.
it's an agentic RAG, agent will automatically handle it with its memory. If it's a regular RAG, you'll have to add a
Yeah.
layer of query reconstruction, so that every time you ask a question, it sees whether it is relevant or not. And there is also a thing
Yeah.
called as self RAG. If you have seen this, let me show you agentic RAG. So there is this diagram I would like to show you. So see this. This is an agentic RAG. What happens that agent decides to execute a function call. So it sends a question that you add a layer whether I want to do RAG or I don't want to do RAG. Right? So if you want to do RAG, you will come here, you'll make the retrieval tool call, and you'll get the documents. Then you will ask whether
Okay.
these documents are relevant or not. If they are relevant, you'll further generate the answer, else you will come back in the loop. So this is also another strategy to in production systems to enhance it.
Like page index only until the
Yeah,
documents are not.
and the documents are answered. Yes. So this is called as self-RAG. So there is a research paper for this as well. You can read it as self-RAG. Okay. So
Sure.
learning to, so what does it do? It says that when to retrieve, when to generate and critique yourself before going to RAG. So whenever it goes
So
to, it does not directly go to RAG. It always criticizes itself, question itself, do I even need a RAG, or I need a web search, or I don't need at all anything. Let's say if you're
sure, sure.
asking what is the capital of France, you don't need RAG for that. LLM knows that, right? So it's
So
something like this.
currently we are working with the like approach like corrective RAG, where RAG information is not enough for the answering. So we use
Yeah.
web context also for answering the user query.
Yeah. Correct. That is called corrective RAG, where you fetch information from web and improve your chunks.
Yeah. Yeah. Thank you so much.
Yeah, but these are the major strategies that we use in production systems. Okay.
Sure.
So anyone, any other question?
Yeah. Can you just provide the GitHub URL in chat?
Yeah, I'll share on the group. I'll upload this video on YouTube,
Yeah, yeah,
and
sure.
I will add the GitHub URL, PPT, everything in that, so that things can stay in one place, right? So you can refer from there. You are in the group, right?
Yeah, 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 sure.
So I'll share the video by tomorrow morning, so you will be able to see it.
Thank you.
Thank you. Anyone, any other question? Or let me
My
close this
group
recording.
AI discussion group.
Sorry.
AI discussion group, right?
There is another group. I'm not the admin there. There's another group, AI builders. So I generally post on that. I'll put on the. You can text me. I'll share you the link. But I'll put on AI discussions as well in that video, so you can check them. But I put all my content in another group called as AI builders, so you can check from there.
Uh, Can I join it?
Yeah, you can join. Just WhatsApp me after this